Today's topic is on intensity and derivation of L minus L naught. This is the topic today. And first, we will define intensity, or you write that define intensity and its unit. So first of all, we will define what is intensity. So basically, intensity is energy per unit area which is perpendicular to propagation of sound waves. Per unit time. This is the definition of intensity. So if you write this thing, it will become easier to describe it. So intensity is energy per unit time per unit area which is perpendicular to the sound waves. This is the definition of intensity. In Urdu, we call it shiddat. For example, the intensity of sun rays is increased in summer and the intensity of sun rays is decreased in winter. सर्दियों में सूरज की धूप की इंटेंसिटी कम होती है और गर्मियों में सूरज की धूप की इंटेंसिटी ज़्यादा होती है, शदीद होती है. So intensity is from shiddat, shadid hona. So the sound which possess greater energy is shadid sound. Understand? Intense sound or intensity is greater. Now we will come towards the unit of intensity. For unit of intensity, we will again refer to this formula. I has unit equal to, what's the unit of energy? It is joule. Per unit of time, it is second. Per unit of area, it is meter square. What is joule per second? It is basically watt. Joule per second is watt. And this can be written as per meter square. Also, we got the unit of intensity as watt per meter square. So this is the unit of intensity. Now in the same topic, we will describe second thing. Give some examples in which human ear responds to the intensities. So we will start from the beginning level of intensities, and that is 10 raised to power minus 12 watt per meter square. It is basically faintest intensity human ear responds. Next, we come towards 10 is for minus 11 watt per meter square. It is intensity in the rustling of leaves. यानी पत्तों की जो सरसराहट है, rustling of leaves possess energy, and that energy comes over here in the form of intensity. कि उस के अंदर जो एनर्जी पाई जाती है, उस एनर्जी की वजह से शिद्दत कितनी हो जाती है, how intense that intensity it is in the rustling of leaves, and that is 10 raised to power minus 11 watt per meter square. Next we come towards 10 raised to power minus 8 watt per meter square. It is buzzing of mosquitoes. Intensity in buzzing of mosquitoes, and that is 10 raised to power minus 8 watt per meter square. At fourth, we will take 10 raised to power 0 watt per meter square, and that is intensity in sound of siren. You hear the siren if you are nearby. Its intensity is 10 raised to power 0 watt per meter square, or as you know, it is equal to 1 watt per meter square. After it, we start feeling pain. All the intensities which are greater than 1 watt per meter square gives pain to the ear, and its example is here its example is 10 raised to power 3 watt per meter square, and that is intensity for sound of jet plane. If you are nearby or a jet plane is passing nearby somewhere, its intensity level is 1000 watt per meter square, 10 raised to power 3 or 1000 watt per meter square. And this is the starting level, faintest intensity for which human ear responds, and usually it is given the name as reference intensity, and reference intensity is denoted by I naught. Reference intensity is denoted by I naught. What is I naught? So we can write I naught is equal to 10 is power minus 12. And we can symbolize it as rustling of leaves, I for rustling of leaves. And we can denote it as I for buzzing of mosquitoes, and this for I is equal to siren, and this I is equal to jet plane. So you see, I naught is faintest intensity, or we call it reference intensity denoted by I naught. I naught and its value is 10 is power minus 12 watt per meter square. These are some intensities given over here, but there are billions of intensities for each sound. So we can say we have a very wide range of intensities. We have a very wide range of intensities. Say starting from 0, it becomes 1, 2, and so on up to 10. Then it comes up to 100. Then it again expands up to 1000. Then it comes up to 10,000. Then it will become 100,000 and so on. There are millions, billions intensities of different sounds. So this is very much wide range. How to shorten this range? We use log to shorten this wide range. How? You can say we take log of these all numbers. So log of 0, log of 100, log of 1000, log of 10,000, log of 100,000, and so on. What is the value of log 0? Log 0 is 1. Log 100, you may calculate it on calculator. Log of 100 will come, this is log of 10 will come, this is log of 0 is 0, log of 10 is 1, log of 100 is 2, log of 1000 is 3, log of 10,000 is 4, log of 100,000 is 5, and so on. Here you see we have shortened wide range of intensities. So that's why in a derivation we will just write a sentence that we will use log for a wide range of intensities. We will just use a single sentence, and then we will start describing it in the form of log. So this was a thing you would have to understand, that we have a very wide range of intensities for different sounds, and we take log of these. So we shorten that wide range into a short range like this. Now we can grasp this range. 0, 1, 2, 3, 4, and so on. But how? By using log. Now we will come towards third part, and third part is derivation of difference of sound levels. We have to calculate the difference of sound levels starting from L0 up to some level of sound. Now for it, we will say that loudness L is directly proportional to intensity I. If intensity is greater, energy is greater, then the loudness is greater. We know this thing. But we will just write a single sentence over here as range of intensity is very wide, so we use log over here. So we can write it as loudness is directly proportional to log of I. Converting this relation into equation, we get L is equal to K into log of I. So we have got this equation 1. Similarly, we can write L naught is equal to K log of I naught. You know I naught, reference intensity, and its value is 10 raised to the power minus 12 watt per meter square. No need to describe it over here. We just give it a name, equation number 2. We have to find the difference of L naught and L. How will we find the difference? Subtract equation 2 from equation 1. So we get L minus L naught is equal to K log I minus K log I naught. K is common, and apply the law of log. We get log I divided by I naught. This K is common, and log I minus log I naught is application of law of log. As we know, log of A minus log of B is equal to log of A divided by B. This law of log is applied over here. No need to describe it over here. So we have got a sound, loudness of sound starting from 0 level up to this particular level. The value of K is equal to 1 in certain experiments done. Those experiments are not included in your syllabus, but we will use the value of K as 1. So we got L minus L naught is equal to log of I by I naught in unit bell. What is the unit? Its unit is bell. The sound intensity level is given in bell, but bell is very bigger unit. So we will shorten this bell also into decibel. How we are going to convert it into decibel? If we have its 10th part, then what we are going to do is, here you see, we will write L minus L naught is equal to log of I by I naught, and here 10 into 1 by 10 into 1 by 10 bell. This 10 will come in the starting and we will get 10 log of I by I naught into 1/10 of a bell. 1/10 means deci and bell B. So we got this formula, L minus L naught is equal to 10 into log of I by I naught decibel. This is the formula we will use in numericals. And what it means? It means, for example, you have a knob known as volume in TV or in radio, and L naught, it starts from L naught, 0, 1, 2, 3, and so on up to some level N. Here the sound is completely shut down. No sound is heard. You increase the volume and thus sound becomes louder and louder. So this is the level. L minus L naught means you are increasing the sound level. So you have to understand what is meant by L minus L naught. L minus L naught is similar to a foot scale. You have 0 centimeter, then 1, then 2, then 3, and so on. In a foot scale you have 0, 1. How you measure the length of something? You measure it 3 minus 0 means length. If this is showing the length, say L naught, and this is some length L. So how you find the length? Basically you find the length delta L is equal to L minus L naught, or you say 3 minus 0 is equal to 3 centimeter. So the length of this chalk is 3 centimeter. But practically we do not do like this, that you will put a chalk and you will say 3 minus 0 is equal to 3 centimeter. You just say it is 3 centimeter. This thing is understood, that we just write or we just say it is 3 centimeter. In the same way, when we find sound intensity level or sound level, we just do what? We increase the volume from L naught up to certain level L. It may be 1, 2, 3, 4, 5 or whatever. So this we have to derive L minus L naught is equal to 10 log of I by I naught in decibel.